Alright guys, today we're going to be going over our Module 3 test review. So our first question says, write an equation for the following graph. Now, this is a line, so we know this is linear. We know we're going to be using our slope-intercept form, y equals mx plus b, where b is our y-intercept and m is our slope. Remember, we always want to start with our y-intercept. That is always our start. So I'm going to look at my graph and I'm going to look at where does my graph touch the y-axis. This is our y-axis, this is our x-axis. It touches right here at 1, 2, 3. So I know our y-intercept is positive 3. Now I want to look for my slope, my rise over run. Now remember, rise over run tells us first, it tells us our rise, how many do we go up or down. So we're looking at our rise, up or down, and then we're looking at our run, left or right. So in this case, we're going down by 1, 2, 3, 4. We want to get to this point. So since we're going down 4, we're going to be negative 4, and then we're going to the right 1, 2, 3, 4, 5. Negative 4 over 5, and that's going to be our slope. So when we incorporate our slope over here, x doesn't change, y doesn't change. And there's our equation. All right, let's go to number 2. So number 2 says, write 4x minus 5y equals 18 in slope-intercept form. So I know slope-intercept form is y equals mx plus b. Now, this is not in the same format. This is standard form. So I want to make sure that I get my standard form into slope-intercept form. Now, I do this by getting y on one side of the equal sign by itself. So that's what I'm going to do in this case. I'm going to put a box around y because I know I'm going to be isolating that variable, and I'm going to move everything else to the other side. I'm going to start by moving this 4x. I know the opposite of positive 4x is negative 4x. Negative 4x. I cannot combine these two terms. I cannot combine 18 and negative 4x because they are not like terms, so I'm just going to rewrite them down right next to each other. My 4x's are gone. I'm left with negative 5y. From here, I'm going to get rid of this negative 5, so I'm going to do the opposite. I'm going to divide by negative 5, divide by negative 5, divide by negative 5. My 5's go away. They don't cancel because negative 5 divided by negative 5 is not 0, but they give you a 1, and 1y is the same thing as just having a y. Our two negatives create a positive, so we're left with 4 over 5x minus 18 over 5. All right, let's go to number 3. So number 3 is a lot like number 2. In that it is not in slope-intercept form, and I want to make sure I use slope-intercept form to graph it. So I'm going to get it into slope-intercept form. I'm going to start by isolating y. So I'm going to move everything else to the other side. I'm going to start with my x because I don't need it. I can't combine 20 and negative 2x, so they don't go together. I'm just going to write them right next to each other. Bring down my 5y. All right. I'm going to divide by 5 to get rid of that 5. Whatever I do to one side, I must do to the other. I'm left with negative 2 over 5x plus 4. All right, and now we graph. We know our y-intercept is 4, so I'm going to go up to 4. And my slope is down 2 to the right 5, so I'm going to go down 1, 2. In this case, we're counting by 2s. To the right, 2, 4, 5. Down 2 to the right. To the right, 1, 2, 3, 4, 5. And there we go. We're going to connect our dots. And there is our graph. All right, now let's move to number 4. All right, looks like 4 has 2 parts. We're going to be solving for a and b. So it says Susie's bank account is represented by the following equation: y equals 120 plus 30x, where x is then the months that have gone by and y is the money in Susie's account. Susie started with blank dollars in her account and was depositing blank a month. So our equation is y equals 120 plus 30x. Well, I know this is supposed to be in slope-intercept form, so I'm just going to switch the order of these two. That way it's in the format that I like it. Okay, so following my y-intercept, this is always where we start. I'm going to look at my problem. It says Susie started with. So I know that wherever her start amount is, I know it's the y-intercept, because our y-intercept always represents what we start with. So I already know that part A is 120 because it told me that she started with, and I know keyword for the y-intercept is start. Now I want to know how much she's depositing in her account a month. So I know X represents the months that have gone by and what numbers attached to X. We have our 30. This should be a 30, sorry. We have our 30. So every month she deposited $30. And there's my answer. All right, let's go to number 5. So it says, what is the average rate of short tons from 2000 to 2002? So we're talking about million short tons versus the years. So we're looking at years 2000 to 2002. Well, I'm going to go to 2000. 2000 seems to be on my y axis. So I'm going to put that at 2000, comma 60. And 2002 seems to be right here. We are looking at 2000, comma 40. 2002, comma 40. All right, now we want to know average rate of change. We know our average rate of change formula is the same as the slope formula, y2 minus y1 over x2 minus x1. I know I started at 2000, so that's going to be my x1, y1. I'm going to 2002, 40. And now we just plug it in. Make sure you format it. That way you don't forget your negatives in between. And now we start plugging it. Y2 is 40 minus 60. 2002 over 2000. 40 minus 60 is negative 20 over 2002 minus 2000 is 2. And we're left with negative 20 divided by 2 is negative 10. So on average, they are going down 10 million tons. All right, let's go to number 6. So number 6, we have average rate of change. So we already know what the formula for average rate of change is. Y2 minus y1 over x2 minus x1. So now we're just going to plug in. We know we're starting at 5, comma negative 9. So this is my x1, y1. We're going to x2, y2. Set up your format. All right, we've got negative 2 minus negative 9. 3 minus 5. All right, two negatives right next to each other create a positive. So we've got negative 2 plus 9. We have different signs, so we keep the sign of the bigger number, so we know it's positive. Find the difference from 2 to 9, we have 7. And then on the bottom, this should be a subtraction. We have 3 minus 5, which is negative 2. We're left with 7 over negative 2 as our average rate of change. All right, let's head over to number 7. All right, 7 is a simple interest equation. It says Sam opens up a savings account at Wells Fargo. Sam deposits $3,000 into a simple interest account with an interest rate of 4%. Assuming he does doesn't deposit or withdraw any more money, how much will he have in 12 years? So there should be doesn't, sorry. Doesn't. All right, so let's fall back on our simple interest formula. So we have A equals P times 1 plus RT, where A is our principal, R is our rate, and T is our time over years. All right, so let's start with principal. We're solving for A. We want to get the value of how much money he's going to have after 12 years. So we're solving for A. So our principal is how much he starts with. He started with $3,000. 1 plus, then our rate. Our rate is 4%. What's 4% as a decimal? That's going to be 0.04. And then we are multiplying it by time. Our time is 12 years. All right, and then from here, we just follow PEMDAS. You want to make sure you start with your parentheses first. We're going to do 0.04 times 12. We're going to get 0.48 plus our 1 times our 3,000. Then we're going to do 1 plus 0.48, which is 1.48. And we're going to times that by 3,000. And we will have $4,440 in our account, or in Sam's account, after 12 years. All right, so let's head over to number 8. Okay, so for 8, we're going to be graphing an absolute value equation. So I'm going to start by creating my T-chart. Okay, this is what's gonna look like. All right, and I'm going to give you the points you're going to be trying to plug in. And 0. All right, so we're gonna be doing some different style points. We're gonna be doing 0, 2, and then we're gonna do a little something different. We're gonna plug in for our Y to get our X value. All right, so we're going to start by plugging in 0. We're going to do -3 times 0 plus 2. All right, well, the whole thing is in the absolute value, so I'm going to start with multiplication. -3 times 0 is 0, plus 2 is 2. The absolute value of 2 is 2. So I should have 0, 2. 0, up, 1, 2. Then we're going to plug in 2. We have -3 times 2 plus 2. -3 times 2 is -6 plus 2 is -4. The absolute value of -4 is 4. So we have over 1, 2, up 1, 2, 3, 4. And finally, we're going to plug in 0 for Y. So we're going to have 0 equals -3x plus 2. So I'm going to move over this 2 to the other side by doing the opposite operation. We are left with -2 equals -3x. Divide by -3, divide by -3. X equals 2 over 3. And that's going to be our X value. So for this one, you're going to have -2 over 3, 0. So we're going to go over 2 over 3, which is somewhere over here, up 0. And I know it doesn't look like it, but when you connect the dots, it's going to give you a V shape. All right, let's go to number 9. So for number 9, we want to find the y-intercept. So first we need to know that y-intercept as a point is 0, comma y. So I know I'm plugging in 0 for x. So that's what I'm going to be doing over here. We have y equals 3, absolute value 2 times 0 minus 4 plus 2. So I'm going to start by solving the absolute value. 2 times 0 is 0 minus 4. Bring everything else down. 0 minus 4 is negative 4. Bring everything else down. Now, the absolute value of negative 4 is positive 4. So I'm going to substitute the absolute value for parentheses. That way I know that I finished. I did the absolute value. I don't have them anymore. From here, we want to follow PEMDAS. We've got multiplication. 3 times 4 is 12 plus 2. We get 14. So the y-intercept is 0, comma 14. Finally, we have number 10, identify the x and y intercepts. So I know the x-intercept is where it touches the horizontal line. So I'm going to look at our horizontal line. This is my x. It's going to be touching right here. I also know x-intercepts are in the form of x, comma 0. So my x-intercept is going to be negative 2, comma 0. Now we're going to look at our y-intercept. Where does it touch the y line, the vertical line? I know that's going to be in the format of 0, comma y, and it is touching right here at 4. So we have 0, comma 4. All right, and that's it for this module test review.